Scientists are on a quest to understand black holes, using telescopes, computer simulations, and observations to study their formation, behavior, and impact on the universe. Black holes are formed from the collapse of massive stars and are punctures in the fabric of space-time. They are more common than we think, with many galaxies having immense black holes at their centers. These supermassive black holes can shape galaxies and seed them with elements. The video also explores the concept of wormholes, violent nature of black holes, and their potential role in the formation of celestial bodies. Additionally, the video delves into the Earth's climate engine, the importance of life in regulating carbon dioxide levels, and the impact of human activity on the planet's climate. It concludes with discussions on preserving and protecting the Earth and the dramatic geological events that have shaped its history, such as mass extinctions and supervolcanic eruptions like the Toba eruption. Scientists are on a quest to understand black holes, which are some of the most elusive objects in the universe. They are using the telescope called SWIFT, which is designed to detect bursts of high-energy radiation called gamma rays. These gamma rays erupt when a black hole is born from the explosion of a large star. The force that triggers this chain of events is the same force that rules the cosmos. We learn about how gravity is not a mysterious power projected by objects like the Sun, but rather a result of space itself. Albert Einstein's theory of relativity proposed that gravity is the warping of spacetime caused by massive bodies, creating a dent in the fabric of spacetime. This concept is exemplified by red supergiants, massive stars that collapse in on themselves, forming black holes. Black holes are a million times smaller than the Earth but have a million times its mass. They are punctures in the fabric of space-time, with an event horizon beyond which nothing, including light, can escape. Black holes are more common than we may think, with astronomers detecting dozens in our galaxy and estimating there are tens of millions more. Furthermore, nearly every galaxy has an immense black hole at its center, such as M87, which has a black hole 4 billion times the mass of our Sun. These black holes leave a signature of powerful jets erupting at nearly the speed of light. Scientists try to trace the origins of supermassive black holes by recreating the early universe through supercomputer simulations. They find that gravity plays a crucial role in the formation of galaxies, drawing together primordial gases that eventually ignite and give birth to the first stars. As these stars die in powerful supernovas, their cores collapse into black holes. Over billions of years, some black holes grow larger by plowing their way to the centers of their host galaxies and feeding on gas and stars. Others grow even larger when they collide with other black holes, merging into a single powerhouse. These supermassive black holes can produce blast waves that sculpt and shape galaxies, seeding them with elements like carbon, oxygen, and iron. Astronomers are trying to determine if our own galaxy, the Milky Way, has a supermassive black hole at its center by tracking the speeds and orbits of stars swirling around it. The video explores the existence of a supermassive black hole at the center of our galaxy. Although it cannot be seen directly, researchers have confirmed its presence through calculations and observations. Using telescope observations and computer models, the video takes viewers on a virtual journey towards the black hole. As they get closer, they encounter a crowded and chaotic region filled with dust, stars, and hot gas. The black hole's voracious appetite pulls in gas and ejects it back out, creating a swirling cloud of superhot gas. The video then visualizes the journey into the black hole, revealing a warped space where light is twisted by the black hole's gravitational pull. Crossing the event horizon, the point of no return, the inside of the black hole is not dark but instead filled with a maelstrom of energy and matter known as the singularity. The concept of a wormhole is explored, which is a theoretical passageway in space and time that could potentially allow travel to other universes. However, it is mentioned that the inside of a black hole, where a wormhole could potentially form, is too violent and dangerous for this to actually occur. The violent nature of black holes is described as nature's ultimate fury and destruction on a scale beyond comprehension. Despite this, it is suggested that black holes have played a role in shaping our galaxy by seeding it with elements and potentially helping to form celestial bodies like stars and planets. The search for the answer to what a black hole truly is leads to the discovery of dark mysteries and revelations stolen from the other side of infinity. The video discusses how the Earth operates and why it is conducive to life. Scientists have launched satellites to understand the inner workings of our planet, discovering answers in its atmosphere, oceans, and continents. It is revealed that the Earth's parts were forged in distant supernova explosions, which showered the galaxy with heavy elements. The Sun provides a shield, deflecting cosmic rays and dangerous solar winds. Unlike Venus, where solar storms strip away its atmosphere and leave behind a toxic environment, Earth has its own protective shield that has allowed it to avoid such a fate. The power of Earth's climate engine is explored, which is driven by the unevenness of solar heating and the movement of wind and ocean currents. The Gulf Stream is highlighted as an ocean current that carries enough heat energy to power the industrial world 100 times over. The complexity of Earth's climate system is emphasized, with various factors working together to equalize temperatures around the globe. However, when tropical heat reaches extreme levels, it can result in the release of energy in the form of intense hurricanes like Hurricane Katrina. A supercomputer model is used to better understand the dynamics of hurricanes, showcasing how warm winds fuel the storm and increase evaporation from the ocean. It is revealed that a powerful hurricane like Katrina can release as much heat energy every 20 minutes as a 10-megaton nuclear bomb. The video highlights the importance of life on Earth in regulating carbon dioxide levels and maintaining the delicate balance of our planet. Phytoplankton, tiny organisms in the ocean, play a crucial role by absorbing CO2 and releasing oxygen. This carbon then moves up the food chain as these phytoplankton get eaten by other organisms, from zooplankton to larger fish and eventually predators like orcas, tuna, and sharks. At each step, the carbon becomes part of the mass of these larger animals. Even whales, like humpbacks, consume a significant amount of food per day, contributing to the storage of carbon. This interconnected web of marine life is part of a global system that helps remove CO2 from the atmosphere and release it back over time, ultimately sustaining the carbon cycle on Earth. The carbon cycle and its importance in making the Earth habitable are explored. Through the process of photosynthesis, plants release oxygen and absorb carbon dioxide. When plants and animals die, the carbon can find its way into the ground and eventually into the oceans through erosion. In the marine food chain, carbon-rich matter can sink to the sea bottom and accumulate over time, turning into oil or rock. However, the carbon cycle relies on life itself, and if it were to go wrong, it would have dire consequences. On Venus, which is like a house on fire with its windows forever closed, the carbon dioxide emitted by volcanoes remains trapped, leading to extreme heat levels. This is in contrast to Earth, where the balance of absorbing and releasing carbon dioxide has been maintained. However, human activities have disrupted this balance, with carbon dioxide levels increasing significantly since the Industrial Revolution. This has resulted in rising global temperatures and the accelerated melting of ice. The consequences of these changes include shifts in rainfall patterns and the potential transformation of our world. The video highlights the impact of human activity on the Earth's climate and the increasing awareness of our planet's interconnected systems. As our understanding of the Earth expands through space technology, we realize the urgency of addressing climate change. The video concludes with the question of whether our goal should be to preserve and protect the Earth or exploit its resources. The following section transitions to a discussion of the dramatic geological events that have shaped our planet's history, such as mass extinctions and supervolcanic eruptions. We learn about the devastating eruption of the Toba supervolcano 74,000 years ago on the island of Sumatra. This eruption, the largest volcanic eruption in at least 25 million years, spewed out nearly 3,000 cubic kilometers of ash and rock, covering an area half the size of Europe. The eruption caused a global cataclysm, plunging the planet into a volcanic winter with average temperatures falling by up to 10 degrees Celsius. The aftermath of Toba's eruption resulted in years of darkness and drought, impacting the Earth's climate for possibly 1,000 years. We learn about the Toba eruption and how it affected our ancestors, potentially bringing them close to extinction. The episode explores the formation of our planet billions of years ago and how the heat energy from the Earth's interior escapes through volcanoes, especially along the Ring of Fire. The collision of oceanic and continental plates, along with the presence of water, creates the secret ingredient for volcanism, causing rocks to melt. This video explores a variety of cosmic phenomena, starting with volcanoes on different celestial bodies, including Earth, Triton, and Io. It then delves into the Great Dying, an ancient event caused by a massive volcanic eruption that led to a mass extinction. The race to the moon between the Soviet Union and the United States is also discussed, along with the moon's origins and its violent history. The moon's topography, interior, and the presence of water are examined, with implications for future exploration. Furthermore, the video explores the search for Earth-like planets and the role of water in the formation of our solar system. The differences between Earth and other planets in terms of their ability to sustain life are also highlighted, emphasizing the importance of a protective magnetic field and a stable climate. In the YouTube video titled An Exploration of Cosmic Phenomena, Secrets of the Universe, Season 1 all episodes, Spark, scientists discuss the search for planets outside of our solar system that may have the potential to sustain life. They explore the discovery of exoplanets, planets that exist outside of our solar system, and how astronomers use various methods to detect and study them. The video also touches on the search for habitable planets and the potential for finding signs of life on these distant worlds. Additionally, it delves into other cosmic phenomena such as supernovae, neutron stars, black holes, and the evolution of our understanding of the universe throughout history. Overall, the video sheds light on the remarkable diversity of the cosmos and the mysteries it holds. In this YouTube video titled An Exploration of Cosmic Phenomena, Secrets of the Universe, Season 1 all episodes, Spark, astronomers Edwin Hubble and Milt Humason discovered that nebulae were actually galaxies far beyond our own, moving away from us. This led to the understanding that the universe is filled with countless galaxies constantly growing larger. As astronomers peered deeper into space, they realized they were also looking further back in time, revealing a dynamic realm shaped by exploding stars, shock waves, and black holes. The Big Bang Theory emerged as the origin of the universe, supported by the expansion of the universe, a common starting point for all matter and energy, light elements, and the stretching of light emitted in the early universe. Recent measurements indicate that the universe is approximately 13.7 billion years old. The video also explores the immense size of our galaxy, clusters of galaxies, and beyond, suggesting the existence of multiple universes that may coexist side by side. See more.